Hello friends. So in this video we will talk about the data formats and type. So in the data formats we have two formats, fixed point data and the floating point data. The floating point data is further divided into two types, single precision that is 32-bit and double precision that is 64-bit. Now in the fixed point data, we have two format, magnitude format and complement format. In magnitude format, we have unsigned format that is used for only positive data, and we have signed magnitude format that is used for the both positive and negative data. In the complement format, we have two types, one's complement and two's complement, and both of these formats are used for representing both positive and negative data. In the sign magnitude, so in the last video we saw that in the sign magnitude format the MSB bit is used for sign and the value is taken from all the remaining bits, right? Now let's talk about the ranges that is given, like if we have given the n bit like number, how many numbers we can represent using each of these formats. So if the bit is of like size n, we can represent a 0 to 2 to the power n minus 1 in unsigned format. So if we take an example of 4-bit range, so if we like put here n is equal to 4, it would be 0 to 2 to the power 4 minus 1, that is 16 minus 1 15. So we can represent 0 to 15, that is 0 1 2 3 4 5 till 15 number in a 4-bit data. Now in the sign magnitude format we can represent here minus 2 to the power m minus 1 2 plus 2 to the power n minus 1 minus 1. So if you put here n is equal to 4, it would be minus 7 to plus 7, and this is same actually in the ones complement format, so it will also be minus 7 to plus 7. In the twos complement format we can represent minus 2 to the power n minus 1 2 plus 2 to the power n minus 1 minus 1. So if we put n is equal to 4 here, it would be minus 8 to plus 7. We now see from where these ranges came, and we will discuss like in detail about all these formats now. So let's see. Here we have created this like table. We have this 4-bit binary code from 0000 to 1111, and then we have these four formats, and here we are talking about only fixed point data, and we will talk about this floating point data later. So in the fixed point data we have these four formats: unsigned, signed magnitude, ones complement and two's complement. From this table we can see that here the MSB is 0. That means these numbers are like positive due to the symmetry of binary numbers, and these numbers will be negative. But in the unsigned data all will be like positive, because here you see that only positive data can be represented using unsigned data. So there is no problem in unsigned data. We are starting from 0000, so it is 0, then 1 2 3 4 5 6 7, and this is 8. These are negative numbers only in sign magnitude, ones complement and two's complement, because this format can represent negative numbers, but these are positive in unsigned as well. So everything is positive in unsigned 0 to 15. So here we saw that for the 4-bit range we have 0 to 15, so it is coming from here only, from 0 to 15. In the 4-bit binary code we can represent 0 to 15 in the unsigned data. Now for all the positive numbers we can see these numbers are same in all the formats. This is what we can derive from this table. So if the number is positive, that is if the MSB bit is 0, all the numbers are positive and same in all the formats, right? So this we can note that no complement of positive data. So if someone will ask you to find the complement of 0001, don't do like, so 0001, don't do like invert the bits 111 and 0 and just call it that it is 14 or things like that. because as the number every MSB bit is 0, the number is positive, so the ones complement will be 1 only, two's complement will be 1 only, sign is 1 only, because we don't invert the bits in one's complement for positive numbers. We don't invert the bits and add 1 to find two's complement in the positive numbers. Now the values in this formats, sign, ones and two's complement formats, will change only for the negative numbers. So in the last video we saw like how to find the sign magnitude like values, one's complement values and two's complement values. Let's talk about the sign magnitude format. Here uh, the third column. So how you will find the sign magnitude? Suppose we are talking about this 1001. So this 1 is for sign, MSB bit. Here in the sign magnitude format, the MSB is for sign and the remaining is for value. So this 1 is for sign. So 1 means this negative, and this 001 means 1. So this is how we find the sign magnitude data. Similarly, if you talk about this, this 1 is for sign, that is minus, and then 101 is 5, so minus 5. This is how we calculate the sign magnitude data. We know how to calculate the ones complement data. We just invert the bits, and if we invert the bits and then add 1 to it, then we can get the two's complement data. For example, if we talk about this 1000, if we invert it, we will get 0111, that is 7, and as it is negative number, we will have minus 7 right here. If we have to find the two's complement, we will get the ones complement here by inverting the bits, and then we will add 1 here. So 110, 110, 110 and 1. So this is 8 and the sign will be negative. So this is how we get the two's complement. If we have like one complement already, and if we need to find the two's complement, don't do like this. Suppose if we have minus 7 in one's complement, don't go and add 1 to it and say that minus 6 is the two's complement. We add 1 to the magnitude and then take the sign separately. So do something like this: we add 1 to magnitude and then take the sign, so it would be minus 8. So if we have given the ones complement, we can add 1 like this to the magnitude and then take the negative sign to find the two's complement. So this is how we find the sign magnitude, ones complement and two's complement. So we will also see some like examples, but here uh, there are like two interesting things here in the sign data. So for the 4-bit data, we can represent maximum 16 numbers. We know that, right? 2 to the power 4 is equal to 16. So in the unsigned data, we can see we are representing from 0 to 15, that is 16 numbers, so it is fine. In the two's complement data, we are representing minus 8 to minus 1 and then 0 to 7, that is 8 here and 7 8 here and then 7 here and then 0, means 8 7 15 and 1 16, 16 numbers here as well. But in the sign magnitude data and the ones complement data, we are representing only 15 numbers here, because we are representing this 0 with the two numbers plus 0 and minus 0. So here we have 1 to 7 7, 1 to 7 7, 7 7 14, and this 0 is same only, right? So 7 7 14 and 115. So we are representing 15 numbers in sign magnitude, and similarly here we have two representation of zeros, plus 0 and minus 0. So we are representing 15 numbers here. So this is the first disadvantage of sign magnitude and ones complement, that is we are representing less numbers, right? Here in the 4-bit we can represent 16 numbers, but in this we are representing 15 numbers. So this is the first disadvantage. The second one is this: we are representing 0 using two numbers, plus 0 and minus 0. This is a big problem, right? So this is the second disadvantage, and due to this second disadvantage, that is we are representing 0 using two numbers, we don't use these formats. sign magnitude data and ones complement data. We don't use these two because of this two disadvantages. So what would be the conclusion? To represent the fixed point data, if the data is unsigned, that is here for the unsigned data, we use this format, unsigned data format, and for the signed, that is negative numbers, we use two's complement format here. So we use this unsigned data and two's complement data, and we don't use sign and sign magnitude and ones complement data. This we have for the fixed point data. In the upcoming videos, we will talk in detail about the unsigned format and two's complement format. But before that, we will solve some questions, and to make our concepts more clear, we will solve few problems to find the sign magnitude ones complement and two's complement. We will see like another method to find the two's complement data. We won't talk about this unsigned data because it is like simple binary to decimal conversion, right? So let's talk about this. We will first talk about the signed data format. Suppose we have this number -7, right? And it is given that the format is sign magnitude format, right? This is a sign magnitude format, right? If the number is given and the format is given, then they are asking us to find the binary representation, right? How we will find that? We know that for minus, the MSB will be 1, and for value we will have all the remaining bits. So 7 is 111, like if we are using like 4-bit data. So to represent the -7, we will take the MSB as a sign minus, and then all the remaining 111 for 7. So here we can see for -7 we will have 1111. Similarly, if we have given the binary like number 1111, and then it is asking to find the value in sign magnitude. So this is the like opposite of this. If we have the number and the format, what could be the binary bit? So this is how we find this. If we have given the binary representation and then it is asking the value in the signed magnitude format, how we will do this? It is also simple. We take the MSB bit, so it is 1, so the sign will be minus, and we will find the value of this 111, so it would be 7. So this is how we like convert the value to bits and bits to value in the sign magnitude format. Similarly, if we talk about the ones complement format, if we have given the value -7 and the format is 1 complement, what could be the binary representation of this, right? So how we will find that? We write the binary representation of 7 here, so it will be 111, right? And then this is very important, we put 0 in the MSB, and then we invert the bits, so it would be 1 and then 000, 1000, right? So if we see -7 here, it would be 1000. So so why we like put 0 in the MSB? Suppose we don't put 0 in the MSB and invert the bits of here 111, it would be 000. So this is 0 only, right? So this is why we first make the number positive, right? So if we have to find the binary representation of some number in ones or twos complement, we first take the binary representation of this like magnitude. We make the number positive by putting 0 at the MSB, and then we like invert the bits, so it would be here 100 is the representation of -7, right? So this is the first thing. Now sup- suppose we are having the 1000, the binary representation, and then we have asked to find the value in the ones complement. So how we will do that? It is simple, we just invert the bits. So it would be 0 1 1 1, and we know that it is 7. As this is 1, the sign will be negative, so minus 7. This is how we find the ones complement. Now we will talk about the twos complement. Right? Suppose the number is given as minus 7, we and the format is twos complement. How we can find the uh, binary representation? Similarly, we take the binary of only magnitude 7, that is 111. We make the number positive by putting 0 here, and then we invert the bit and add plus 1. So inverting the bit means 1 0 0 0, and we add plus 1 here, so it would be 1 0 0 1, right? So the binary representation will be 1 0 0 1. So here for minus 7 we have 1 0 0 1, right? Now if we have given the binary representation 1 0 0 0, what is the value in 2's complement? So we take the number, we invert the bits 0 1 1 0, and then we add 1 here, so it would be 1 1 1 0, right? And so this will be 7, and the because of this we have minus 7, because like anyway, if here 0 0 0 1 na, it is just 1. We don't invert and then add 1, because the number is positive, and for positive numbers we won't like find the complement and things like that. If it is negative, then only we are inverting the bits and adding the 1, and like similar in the ones complement, we don't do this complement for the positive numbers. So this is how we find, like if we have the number, we find the binary representation. If we have the binary, we find the value. Now there is one more like method to find the two's complement directly. So the first method is like invert the bits, that is similar to finding the ones complement, and then add 1 to it. So this is the first method to find the two's complement direct, like this one. The second method is we find the two's complement directly without doing inversion and adding plus 1. So how we will do that? We will go right to left, right here, right here, left. So suppose the number is given like 1 0 1 0 0. So how we will find the like two's complement of this number directly? What we will do is we will go from right to left. If we are getting any number of zeros, we will write the zeros at like as it is. If we are getting the first one, we write this one here, and after this first one, whatever we will get, we will invert the bits. So for this number, the two's complement will be this one. So this is how we can find the two's complement directly. So we'll go from right to left. If we are getting any number of zeros, 0 0 1 0 2 0, we will write all zeros that is as it is. We find first one, we write first one, and after this first one we invert the bits. So for example, suppose we have this number 1 0 0 1. So here we don't have any like zeros here, so there's no need to worry about that. We find the first one, so we write this one as it is, and after this first one we like invert the bits. So 0 1 1 1. So here it is. So we can directly find the two's complement in this manner. So like that's all about this video. Now in the next video we will talk about the unsigned format in detail, and after that two's complement format, and after that we will talk about the floating point data. Thank you so much.